Define f from R to R by the rule f of x equals negative x for every real number x. Find f of x. Essentially, we're composing f with itself. The best way I can explain this is by thinking about function composition using this function notation, that f of x is the same thing as f of x as the input of f. So here we have x, which is the input variable. We have f of x, which is the output of f, but it's also the input of this f. And this f of x is the output of this function f. Now, the way I think about this function notation is that here we have an f of x, and we know by this function definition here, by the rule, that f of x equals negative x. So this is the same thing as saying f of negative x. Negative x, even though it's the output of this function, x is the input, negative x is the output. Even though negative x is the output, negative x is going to have a dual nature to it. It's not only the output of the function, but it's also the input of this f. And so that means we have to take this negative x, which was the output, and now this negative x will play the input of our function f. So this is negative x, and negative x is just x. And so we can say our function definition is just f of x equals x, which, by the way, also means that f is the inverse function of f. Normally what you're supposed to show is that if you compose the original function with its inverse function, then you get the identity function, and if you compose the inverse function with the original function, you also get the identity function. This here is the identity function. But in this case, f is its own inverse. So if we compose f with its inverse, that's the same thing as composing the inverse with the original function. Because f and its inverse are the same in this case. F is f inverse. And so this is actually enough justification to also imply that f is f inverse. Just a reminder, that is not an exponent. That does not mean to take the reciprocal of. And the reason for that, number one, is this is a letter. This is a name of a function, and you're not supposed to do any math with names of functions ever. But also because the inverse function is almost never the same thing as reciprocation. Those two things are not the same almost ever. But anyways, this is enough to show that f is its own inverse. Thanks, everyone, and I'll see you in the next video.